So in the last class we have discussed about exact differential equations and how to solve exact differential equations, and today we shall continue that lesson and learn about integrating factors and what are the methods of integrating factors and why do we need integrating factors. So in the last class there was one doubt regarding how to find value of x and y in initial value problems. Suppose uh, I'll solve one question. Say x into right 3x square y square minus 2xy into dx minus x square minus 2xy into dy equal to 0, and given condition is y of 1 equal to minus 1. So there was one doubt of one student that how to find x value and y value from this this condition. So first of all you know how to solve this. Okay, now here m, what is m? M is that multiplied with dx, that is y square minus 2xy. So you find del m by del y, partial derivative with respect to y, so that is 2y minus partial derivative with respect to y, so minus 2x is constant and derivative of y is 1. What is n? N is whatever multiplied with the dy, so that is minus x square minus 2xy. Okay, so del n by del x minus partial derivative with respect to x, so x square derivative is 2x, partial derivative with respect to x, so minus 2y constant and derivative of x is 1. So this is again this is your 2y minus 2x. So both del m by del y is equal to del n by del x, hence given equation is exact, and its solution is given by integration m dx plus integration n dy equal to a constant c, where the integration of m is done treating y as a constant, and integration of n is done only taking those terms without x, without x. So this is implies integration m. What is m? M is your y square minus 2xy dx plus integration n. Now n there are two terms, and all the terms, both the two terms contains x, so you will write 0 equal to c. Now you have integration treating y constant. Okay, y is a constant means y square is a constant, integration dx. Now here minus constant, 2 constant, y is constant, integration x dx, 0 integration 0 equal to c. Now you have y square into integration dx is x minus 2y into integration x, that is your x square by 2 equal to c. So this implies this is your x into y square minus x square y equal to c. This is your general solution. This is your general solution. Now give it equation 2. If you have this question as equation 1, then give this general solution as equation 2. Now we shall apply the given condition. What is the condition here? This is your initial condition. This is your condition. Y of 1 is equal to minus 1. Y of 1 equal to minus 1. Okay, so here we are treating y as a function of x, y as a function of x. So this is written as this. Remember from plus 2 or in 12th class, you know about function, function. Okay, y is equal to fx. Okay, y is equal to fx. The same thing is here, we are writing just y is equal to y of x. Okay, same thing we are writing only what y is equal to y of x. Okay, so the value inside the bracket is actually value of x, and this one is value of what y. So what is x? X is 1, y is what? Y is a minus 1. Okay, here y is a function of x. So comparing this, y of x is equal to y is equal to y of x. As y is equal to fx, from 12th class you know y is equal to fx. Similarly y is equal to y of x. Okay, so the variable within the bracket is x. So x value is 1, and the remaining value is this one is what? This one is value of y. Okay, minus 1 is a value of y. So given applying the condition, I have again I am writing this, given y of 1 equal to minus 1. So this within the bracket, this is x, and this is the value of y. So putting, you will write putting given condition x equal to 1 and y is equal to minus 1 in a general solution, 2 we have now what is the general solution? X into y square minus x square into y equal to c. So here x is equal to minus x is equal to 1 and y is equal to what? Minus 1. X is equal to 1, y is equal to minus 1. X is equal to 1, y is equal to minus 1 equal to c. So minus 1 square is 1, 1 into 1 1, 1 square 1, minus 1 minus plus equal to c. So 2 equal to c. Okay, this is the particular value. Now put c is equal to 2 in your general solution. Here put c is equal to 2 here. So you get required solution is a x into y square minus x square into y is equal to c. What is value of c? Value of c is 2. Okay, so this was the doubt of one student. I thought I will do this first. So now today we shall discuss about integrating factors. Today we shall discuss about what? Integrating factors. Now today we shall discuss about integrating factors. Integrating factor, what is integrating factor? So we'll learn this by an example. First you write the definition. If first write a definition of integrating factor. If left hand side of your question m dx plus n dy equal to 0 is not an exact or we say total differential. What do you mean by this? Till now you know this. By this exact means del m by del y is not equal to del n by del x. Okay, if this happens, then we say that this is not exact. And if this happens, if del m by del y is not equal to del n by del x, as far as you know till now. Okay, till now you know that exact means del m by del y equal to del n by del x, and not exact means del m by del y is not equal to del n by del x. So if this happens, then it is easy to choose a function, suppose u x y, such that after multiplying it, after multiplying by it, such that after multiplying by it, the left side of 1 means this is your 1, the left side of 1 becomes an exact differential. becomes an exact differential. Means after multiplying you will find that del m by del y is equal to del n by del x. Okay. So in that case, that u is called an integrating factor, then that uxy is called an integrating factor, In that case, the u is called an what? Integrating factor. Okay. So whenever you have a differential equation which is not exact, and if you find a function and after multiplying that function you are getting an exact differential equation, then that function is called an integrating factor. Okay. And by the exact means, if I write a definition of exact, differential, or we say this by total differential. In this case, your m dx plus n dy, this will become a d of some function. Okay. If m dx plus n dy becomes differential of some function, then we say that this is exact. And in this case, your del m by del y must equal to del n by del x. Okay. For example, if I write y into dx plus x into dy, say this is your differential of x into y. If I write y into dx plus x into dy, this is your differential of what? xy. You apply u into v formula, u into v, y into the differential of x plus x into differential of y. So this is an exact. And here, what is m? See, del m by del y is del by del y. What is m? M is what is multiplied with dx, that is y, is 1. And del n by del x is del y del x of n. What is n? N is what? That is multiplied with the dy, that is x. This is also equal to what? 1. Okay. Similarly, if I write 1 by y dx minus x by y square dy, now see, this is also exact differential equation. Means if I write y into dx minus x into dy by what? Y square. If I write y dx minus x dy by y square, so this is also equal to 1 by y dx minus x by y square dy. This is also an exact differential equation. Guess, this is your differential of what? Numerator by denominator, x by y. This is your differential of x by y. See, y into dx minus x into d of y divided by y square. This is also equal to 1 by y dx minus x by y square dy. Now in this case also, your del m by del y equal to del m by del x. Del m by del y equal to del by del y of m. What is m? M is whatever multiplied with the x dx, that is your m is your 1 by y. So this is your minus 1 by what? Y square. Similarly, del n by del x equal to del by del x of n. What is n? N is your minus x by y square. Minus x by y square. This is your minus 1 by y square. Different derivative of x is 1. So both the two are equal. These two are equal. Okay. So this is also exact. So whenever you find exact means your m dx plus n dy, this must be differential of some function. And in this case, your del m by del y must equal to del n by del x. This is double implies. Means this is exact, implies this will happen. this will happen, then it must be exact. Okay, so these are the definitions of exact differential equation. And what is an integrating factor? Now integrating factor means it is a function. Suppose I will write a question here, y into dx minus x into dy. Is this exact differential equation? Let us check. What is m? M is multiplied with dx. M is y. So del m by del y is equal to 1. What is n? N is what multiplied with dy, that is minus x. N is minus x. So del n by del x equal to minus 1. Del by del x of minus x, this is equal to what? Minus 1. So this is not equal to del n by del x. Del n by del y is not equal to del n by del x, because this is 1 and del n by del x is what? Minus 1. But it can be made into exact. It can be made into exact. What I will do, I will guess integrating factor. Guess integrating factor. I will solve this by guess 1 by y square. Guess integrating factor is 1 by y square. Now multiply 1 by y square with equation 1. See what happens. 1 by y square into y dx minus x dy equal to 1 by y square into 0. So implies a y of dx minus x dy divided by y square equal to 0. Now y into derivative of numerator minus denominator into derivative of numerator minus what? Minus numerator into differential of denominator divided by denominator square. Now this is a rule. What is this? Is the differential of numerator by denominator. Okay, you know this from school. So this is your nothing but d of what? Numerator is x, denominator is y. So now see, this was not exact, but now this is becomes exact. Okay, you can easily verify this. You can easily verify by writing this as separately 1 by y square into y dx minus x by y square dy equal to 0. So here 1 by y dx minus x by y square dy is equal to 0. This is exact. Okay, here it is same question. Here 1 by y dx minus x by y square dy. Both here del n by del y is minus 1 by y square and del n by del x is also minus 1 by y square. So this is exact differential equation. Okay, this is a exact differential equation. But the original question was not exact. This is not exact. This is not exact. Equation 1 is not exact. But equation 2, after multiplying, you are finding an exact differential. But this is, suppose this is 2, this is exact. This is exact differential equation. So you can convert a non-exact to exact. Okay, here this is equation 1, y dx minus x dy equal to 0. Here m is y, n is minus x, del m by del y is 1, but del n by del x is minus 1. So not exact. Equation 1 is not exact. But whenever I am multiplying equation 1 by this function 1 by y square, I am getting an exact differential equation. I am getting an what? Exact differential equation. This is 1 by y dx minus x by y square dy is equal to 0. This is exact. Here I have already proved that this is exact. Here I have already proved that this is a exact. Okay, this is exact. Now this is your exact. This is your exact. Okay, so this is not exact, but after multiplying 1 by y square, this becomes exact. So this 1 by y square, this function. You are multiplying with a non-exact and converting it to exact. This is such type of functions are called integrating factors. Okay, and in this class we shall learn about 5 methods. There are 5 formulas or rules, you can say 5 basic rules to find out integrating factors. So rule number 1, write methods to find integrating factor. Methods to find integrating factor. Rule number 1, form 1. Better to write form 1. Form 1. Write the form 1. Form 1 is a you have a homogeneous differential equation. If m dx plus n dy is exact, if m dx plus n dy is equal to 0, if this is a homogeneous, and m multiplied with x plus n into y is non-zero. M multiplied with x plus n multiplied with y, this is non-zero. Then 1 by m into x plus n into y is an integrating factor. Okay, so example, remember this from form 1. Now see, solve some examples. Example, solve x square y minus 2x into y square dx plus 3x square y minus x cube into dy equal to 0. Now what is m? M is x square y minus 2x y square. What is n? N is 3x square y minus x cube. So first that is multiplied with the dx. Now first multiply del m by del y, partial derivative with respect to y. So x square is a constant, y derivative is a 1 minus partial derivative with respect to y. So minus 2x is a constant, y square derivative of y square is a 2y. So you have x square minus 4xy. Similarly, del n by del x equal to partial derivative with respect to x. So y is a constant, 3y is a constant. So 3y is a constant, derivative of x square is a 2x. Partial derivative with respect to x, x cube derivative of x cube is a 3x square. What you have 6xy minus 3x square. So del m by del y is x square minus 4xy, del n by del x is 6xy minus 3y square. So clearly del m by del y is not equal to del n by del x. Implies give it some number, equation 1 implies 1 is not exact, 1 is not exact. Okay, 1 is not exact, equation 1 is not exact. But you see both m and n are homogeneous. How? I had already told you a rule to examine homogeneous or not. Now see m is x square y minus 2xy square. How to test homogeneous? You examine how many terms are there. How many terms are there? How many terms? Okay, how many terms are there? 2. There are 2 terms. Then degree of each term. Degree of each term must be equal. Yes or no? Yes. Answer is yes. There are 2 terms, x square y minus 2x cube. What is the degree of x square y? This term degree is 2 plus 1, 3. What is degree of this term? 2 degree is 0, 1 degree of x is 1, degree of y square is 2, again 3. So this equation, this has degree 3, this has degree 3. So m is homogeneous. There are two terms and each of the every term are of equal, that is 3. Okay. Similarly n is your 3x square y minus x cube. There are two terms. What is degree of this term? Degree of 3 is 0, degree of x square is 2, degree of y is 1. So you add them, you are getting 3. What is degree of x cube? 3. So there are two terms and their degree are equal, 3 3. Okay. So n is also homogeneous. Now both m and n, are their degree equal? Yes, its degree is 3, its degree is 3. So this is a homogeneous differential equation. Okay. So we apply form 1. Form 1, what does form 1 says? Form 1 says if m dx plus n dy is equal to 0 is homogeneous, means all the terms are of equal degree. Homogeneous means what? Just roughly remember or roughly understand the meaning of homogeneous, that all the terms are of equal degree. All the terms are of equal degree. Are of equal degree. Just simple. This is only this. Homogeneous means what? What is homogeneous? All the terms present in this question are of equal degree. So degree 3, degree 3, degree 3, degree 3. So all terms are equal. So yes, form 1 can be applied, but we have to check another condition. This x into m plus y into n must be non-zero. So let's verify that x into m plus y into n are non-zero or not. Just a minute. Okay. No, just a minute. You know, in class when in your teacher also takes time to erase the blackboard, so the same case here. I need time to erase the board. Yes, now the board is erased, the board is clear. So let's write. So what I'll do, I'll multiply x with m and y with n, then I will add them. So x into m, what is m? M is here. I have x square y minus 2x y square plus y into n. What is n? Here is n, that is your 3x square y minus x cube. Now I will verify that this is not 0, this is not equal to 0. So now x into x square, this is x cube, y minus 2x square y square plus 3x square y into y, that is y square minus x cube y. So here plus x cube y minus x cube y cancelled. I have minus 2x square y square plus 3x square y square, that is your x square y square. So yes, x square y square, this is non-zero. So if x into m plus y into n is non-zero, then 1 by x m plus y n is an integrating factor. Then integrating factor is 1 by x into m plus y into n. This is equal to 1 by x square into y square. Okay. Now we will multiply this integrating factor with equation 1. So right now multiplying equation 1 by the integrating factor. So multiplying equation 1 by integrating factor. What is integrating factor? 1 by x square into y square. Now equation 1. So multiply this 1 by x square into y square means that is x square y minus 2x y square into dx divided by x square y square. समझ में आया? और I'll simplify this 1 by x square y square whole into this plus 3x square y minus x cube dy equal to 0 into anything is a 0. Now if I multiply 1 by x square y square, this is same to divide by x square y square. Okay, so x square y by x square y square minus 2xy square by x square y square dx plus 3x square y by x square y square minus x cube by x square y square dy implies, now see x square cancel over 1 by y, here y square cancel 2 by x minus 2 by x dx plus here x square cancel, this is 3 by y minus here x cancel, this is x by y square, this is x by y square dy is equal to 0. So your new m is a, I will write this by m1. okay, m1 means this is my equation 2, give it equation 2. I will verify this equation 2 is exact or not. Okay, so let this is a new m means I will write this by m1, that is 1 by y minus 2 by x. Now n n1, write it as n1 means n of the new differential equation 2. This is your 3 by y minus x by y square. Now del m1 by del y, so del by del y of 1 by y minus 2 by x, partial derivative with respect to y, derivative of 1 by y minus 1 by y square, 2 by x constant, so derivative is 0. Similarly del n1 by del x, del by del x of 3 by y minus x by y square, 3 by partial derivative with respect to x, so y is constant means 3 by y constant, so constant derivative 0, 1 by y square constant, del by del x, derivative of x is 1, derivative of x is 1, so this is also minus 1 by y square. Now see, this is minus 1 by y square and this is also minus 1 by y square, del m1 by del y minus 1 by y square, del n1 by del x minus 1 by y square. So write del m1 by del y is equal to del n1 by del x, both are equal to minus 1 by y square. So my equation 2 is exact, so differential equation 2 is exact differential equation. And if 2 is exact, then how to solve it? Its solution is integration my m1 dx plus integration n1 dy equal to c, terms y, treating y as a constant, treating y as a constant, y as a constant, and here terms without x, terms without x, so implies integration m, this is 1 by y minus 2 by x dx plus integration n1 3 by y minus x by y square, this term contains x by y square contains x, so you will not write this term 3 by y, this does not contain x, so you will write 3 by y only, so 3 by y dy equal to c. Okay, implies now 1 by y constant, treating y constant, so 1 by y constant, integration dx minus 2 constant, integration dx by x plus 3 constant, integration dy by y equal to c. So 1 by y integration dx is x minus 2 1 by x integration ln x plus 3 1 by y integration ln y equal to c. So this is my general solution. You can further simplify this by using the ln formulas, formulas of logarithm, that log ab equal to log a plus log b then log a by b equal to log a minus log b, log a to the power b equal to b into log a. So using these formulas I have x by y minus ln x square plus ln y to the power 3 equal to c. Then I have x by y plus ln see this ln a minus ln b is ln a by b, so I can write ln y cube minus ln x square. Okay, then this is x by y plus ln a minus ln b, so ln a by b equal to c. So this is my general solution. This is my general solution. Okay, so this is type this type is a form 1. So now let's move to form 2. If you don't understand, then please watch the video from the beginning again, or you can ask in the comment section. Form 2. Now what is form 2? Form 2 is if this equation has this type of form: y into some function of xy dx plus x into a function of xy dy is equal to 0. If this is your function, this if the question is given in this form, okay, means here what is m? Here m is a y into a function of xy, any function of xy. What is n? N is a x into a function of xy. Okay, and if x multiplied with m minus y multiplied with n is non-zero, then on integrating factor is equal to 1 by x into m minus y into n. Okay, so let's solve an example. You have to remember these forms. Okay, by solving examples you can understand this. Example 1, question is a solve x square y cube plus x into y square plus y into dx plus x cube into y square minus x square y plus x into dy equal to 0. This is given here as your question. This is your question. So I can see that there is y in every term in m, and in n that is multiplied with dy, I can take x from each every term common. So taking common y, I have y into, here you have x square y square plus xy plus 1 into dx plus here I can take x common, here x every term has x. So after taking x, I have x square y square minus xy plus 1 into dy equal to 0. Now see, this is y into xy square plus xy plus 1 plus x into xy square minus xy plus 1. Okay, so this is your function of x. So this is your y into function of xy dx plus x into another function of xy dx, xy dy equal to 0. Okay, so such type of questions are come under form 2. And if you see this type of form, you will verify x into m minus y into n is non-zero or not. Multiply x in m, multiply y in n, then subtract them and see if this is non-zero, then you have your integrating factor 1 by x into m minus y into n. Okay, this is multiplying, this is what, this is m, x into m, multiplying. I am multiplying x into m. So here what is m? M is whatever multiplied with dx, that is x square y cube plus x into y square plus y. What is n? N is what is multiplied with dy. What is multiplied with dy? That is your x cube y square minus x square y plus x. So what you will do? I will verify x into m. X into m minus y into n. X multiplied with m minus y multiplied with n. So x into m. What is m? M is x square y cube plus x into y square plus y minus y into n. What is n? X cube into y square minus x square into y plus x. This is equal to x into, that is your x cube y cube plus x square y square plus x into y xy minus x cube y into y square y cube minus plus x square into y square minus plus minus y into x xy. This is equal to here plus x cube y cube minus x cube y cube plus xy, here minus xy. You have x square plus y square plus x square plus y square, that is 2x square plus y square. Clearly this is non-zero, hence I have my integrating factor. Now what is integrating factor? So you will write, so integrating factor is equal to 1 by x into m minus y into n. This is equal to 1 by 2x square y square. This is your integrating factor. Now your job is to multiply this integrating factor with equation 1. So write now multiplying equation 1 by the integrating factor. I have equation 1. Where is equation 1? This is my equation 1. Multiplying this by integrating factor. First I will write this x square y cube plus xy square plus y. I am writing this x square y cube x square y cube plus xy square plus y into dx plus x cube y square minus x square y plus x whole into dy. You multiply this whole thing by 1 by 2x square y square is equal to 0. Now if you multiply 1 by 2x square y square, this means you have to divide each and every term by 2x square y square. So x square y cube by 2x square y square plus xy square by 2x square y square plus y by 2x square y square whole into dx plus x cube y square by by 2x square y square minus x square y by 2x square y square plus x by 2x square y square whole into dy equal to 0. Implies, now see there x square cancel, y square cancel, you have y by 2 plus y square cancel, x cancel, 1 by 2x plus this is your 1 by 2 x square y whole into dx plus y square cancel, this is x by 2 minus y cancel, x square cancel, 1 by 2y plus 1 by 2x y square into dy equal to 0. Okay, so now you have new m, write it m1 equal to y by 2 plus 1 by 2x plus 1 by 2x square y. Now del m1 by del y equal to del by del y of y by 2 plus del by del y of 1 by 2x plus del by del y of 1 by 2x square y. Y by 2 derivative 1 by 2, del by del y 1 by 2x 0, here 1 by 2x square constant plus 1 by 2x square constant, del by del y of 1 by y, this is minus 1 by y square, so this is 1 by 2 minus plus 1 by 2x square into 1 by y derivative is minus 1 by y square. This is 1 by 2 minus 1 by 2x square y square. Okay, this is del m1 by del y. This is del m1 by del y. Now del n1 by del x, del by del x n1. What is n1? This is my n1. Okay, so x by 2 minus 1 by 2y plus 1 by 2x y square, partial derivative with respect to x, so 1 x derivative 1, so 1 by 2, partial derivative with respect to x, y constant, so constant derivative 0, partial derivative with respect to x, so y constant means 1 by 2 y square constant, derivative of 1 by x, this is also minus 1 by x square, so 1 by 2 minus 1 by 2 x square y square. This is 1 by 2 plus this is 1 by 2y square into del by del x of 1 by x, that is minus 1 by x square. So 1 by 2 minus 1 by 2 x square y square. So 1 by 2 minus 1 by 2 x square y square, 1 by 2 minus 1 by 2 x square y square. So implies del m1 by del y equal to del n1 by del x. So this is my new equation 2. This is exact. This is exact differential equation. Now you can solve it by the rule you know. This is exact differential equation. So you write equation 2 is exact. So equation 2 is exact, and its solution is a integration m1 dx plus integration n1 dy equal to c, y constant, terms without x. M1, what is M1? M1 is a let me erase this area. I can write here. This is easy for me to write here. So integrating y by 2 plus 1 by 2x plus 1 by 2x square y dx, y constant, plus integration, those terms not containing x. So this term will not come, it contains x. This term contains x, so it will not come, only this term will come, that is minus 1 by 2y dy equal to c, constant. Now here y is constant, so y by 2 is constant, so y by 2 take it outside, integration dx. Now here plus 1 by 2 constant, so integration 1 by x. Here y constant, 2y constant, so 1 by 2y integration, this is 1 by x square dx, minus 1 by 2, minus 1 by 2 constant, integration 1 by y dy equal to c. Implies this is y by 2 into integration dx is x plus 1 by 2. What is integration 1 by x? This is formula is ln x plus 1 by 2y. Now what is integration of 1 by x square? Remember, minus 1 by x. Okay, you know, derivative of 1 by x is what? Minus 1 by x square. Okay, so integration 1 by x square is equal to what? Minus 1 by x. So this integration is reverse of derivative. So integration 1 by x square is minus 1 by x. So minus 1 by 2. What is integration 1 by y? It is direct formula ln y. This is equal to c. So now just simplify and write. So this is xy by 2 minus, I will write this term, minus 1 by 2xy, then I will write plus 1 by 2 ln x, then minus 1 by 2 ln y. Now here every term contains 1 by 2, 1 by 2, 1 by 2. So take 1 by 2 common, so I will find xy minus 1 by xy plus ln x minus ln y equal to c. Now take 1 by 2 to RHS, so this is xy minus 1 by xy plus ln x by y is equal to 2c. This is equal to d. Okay, so this is now my general solution. Okay, to see you can write means d means what? D means this is your 2, you to multiply 2 in c, 2c. Now I will denote the by c1. Okay, c1 is my new constant. So in integration we usually do this thing, that whenever you will find a constant multiplied with some 2, 3, 4, 5 or root over or square, you write it c1, c2, c3. This is for simplicity. Okay, this is we do this for simplicity. So I think this is clear now. So this is our form 2. Okay, now let's recall the form 1. What was form 1? Form 1 is your if the equation is homogeneous, means every term, each and all every term are of equal degree. Then if x into m plus y into n is non-zero, then 1 by x into m plus y into n is an integrating factor. Okay, then you have form 2. And what is form 2? Form 2 is if the question look like y into some function of xy into dx plus x into some function of xy into dy is equal to 0, and then if x into m minus y into n is non-zero, then an integrating factor is 1 by x into m minus y into n. Okay, and now write form 2. Form 3. What is form 3? Form 3 is very simple. Suppose you have mdx plus ndy is equal to 0 is not exact. Is not exact. If not exact, then your del m by del y will not equal to what? Del n by del x. Now what you will do? You will subtract del m by del y minus del n by del x. You subtract these two and divide it by n. Divide it by what? N. If this is equal to some function of x, some function of x, a function of x only, a function of x only, or constant, or constant. Either it will become a function of x, or you will find a constant like 1 2 3. Then your integrating factor is, then an integrating factor is equal to e to the power integration this function fx dx. Okay, so let's solve one example. This is a direct formula, nothing to think. You have a mdx plus ndy, you have, this is not exact. So first of all you will test this whether it is exact or not. Find del m by del y, find del n by del x, then see that they are equal or not. If they are not equal, then it is not exact, and if it is not exact, then you will find this their subtraction del m by del y minus del n by del x, then divide by n. If you find fx, then the integrating factor is e to the power integration fx dx. For example, let's solve an example. X square plus y square, x square plus y square into dx minus 2xy dy equal to 0. Okay, now what is m here? Here m is a x square plus y square. What is n here? Here n is a, what is multiplied with the dy, that is minus 2xy. So first you find del m by del y, that is del by del y of m. What is m? X square plus y square. Partial derivative with respect to y. So x is a constant, x square is a constant, derivative of constant is 0. What is derivative of y square? 2y. So you have 2y. Now del n by del x. Now what is del n by del x? Del by del x of n. What is n? N is a minus 2xy. N is a minus 2xy. Now this is equal to partial derivative with respect to x. So minus 2y is a constant, del by del x of x. So this is derivative of x is 1. So minus 2y. So clearly these two are not equal. So del m by del y is not equal to del m del x. So the equation is not exact. Okay, 1 is not exact. Give it equation 1. 1 is not exact. Now this does not belongs to form. Now see, you can verify form 1, but this is not a form 2 question. Clearly form 2 does not fit here. Form 1 you can verify, but I don't think it will come under form 1. If you find this type of situation, del m by del y not equal to del n by del x, and this does not belongs to any form 1 or form 2, then simply what you will do, you will subtract del m by del y minus del n by del x and see what happens. Now del m by del y is 2y minus del n by del x, and del n by del x is a minus 2y. So 2y plus 2y, this is 4y. Okay, now after getting the subtraction, you will see that here n, my n, what is n? N is a minus 2xy. So if I divide this by n, I will divide this by n. What is n? N is a minus 2xy. So divided by minus 2xy. Now see, y cancel, 2, so it is minus 2 by x. Now this is function of x only, function of x only. Okay, if function of x only, you know what is integrating factor. See, this is the formula. Integrating factor is a e to the power integration fx dx. E to the power integration fx dx. What is fx? Fx is this one is fx. So your integrating factor is e to the power integration minus 2 by x dx. So e to the power minus 2 is a constant, integration 1 by x dx. So e to the power minus 2, integration 1 by x is a ln x. You don't write c here, write down, do not write c here. In integrating factor we don't write c. So again, you know, a into ln b, this is equal to ln b to the power a. Okay, a into ln b equal to ln b to the power a. So minus 2 into ln x is this is equal to ln x to the power minus 2. Now this is x to the power minus 2, that is 1 by x square. Now you don't you know the rule, e to the power ln x equal to what? X. Remember this, e to the power ln whatever, e to the power ln whatever, this is equal to that b. E to the power ln b is equal to b. Similarly, ln e is equal to 1. Remember, ln e is equal to also 1. Some formulas of ln, we shall discuss this by solving problems. Okay, I will upload a video regarding the logarithm and logarithm their rules. There are some 10 to 20 results in logarithm. I will write down them and make a special video about that. And for the time being, you just learn what are the required formulas now in solving this type of problem. First one, e to the power ln b is b. E and ln cancel each other. E and ln cancel each other. E to the power ln b is b. Ln is equal to 1. E to the power ln x is equal to x. Ln e to the power x is equal to also x. E to the power ln x is equal to also x. So I have applied here e to the power ln something is something. Okay, e to the power ln something is a something, so x to the power minus 2. So integrating factor is a 1 by x square. So now multiply equation 1, right? Multiply equation 1 by integrating factor 1 by x square. Now again, what was the equation 1? Equation 1 is this here, x square plus y square dx minus 2xy dy. X square plus y square dx minus 2xy dy. Multiply this by 1 by x square equal to 0. 0 into anything is 0. So now 1 by x square, take 1 by x square inside the bracket. So this is x square by x square plus y square by x square dx minus 2xy by x square dy is equal to 0. So 1 plus y square by x square dx minus 2y by x dy is equal to 0. So what is your new m? This give it equation 2. Now here m1 means new m, whatever multiplied with the dx, that is 1 plus y square by x square. What is n? New n, write it n1, whatever multiplied with the dy, that is minus 2y by x. So to check exactness, what I will do, I will find del m by del y. Del m by del y, del by del y of 1 plus y square by x square. 1 derivative 0. Del by del y of partial derivative with respect to y. So x square is a constant. So 1 by x square is a constant. Del by del y of y square. This is equal to 0 plus anything is 0. 1 by x square. Derivative y square is 2y. So this is 2y by x square. Okay. Now what is del n by del x? Del n by del x, new n, that is del n1 by del x. This is del by del x of n1. What is n1? Minus 2y by x. Now minus 2y constant, so del by del x of 1 by x. So minus 2y into what is derivative 1 by x? Minus 1 by x square. So this is also 2y by x square. So 2y by x square, here is 2y by x square. So right, hence del m1 by del y is equal to del n1 by del x. Implies equation 2 is exact. Okay, and you know how to solve exact differential equations. Right? Integration m1 dx plus integration n1 dy is equal to c, terms without x and y constant. So integration m1 plus y square by x square dx, and here in n here is only one term and it contains x. Okay, so I will not write this term, so plus integration 0 is equal to c. N here n is minus 2y by x, there is only one term and it contains x. Okay, so then implies integration dx plus y square is a constant, integration 1 by x square dx is equal to c. So the integration dx is x, y square, what is integration 1 by x square, minus 1 by x is equal to c. So this is x minus y square by x equal to c, implies x square minus y square by x equal to c. Okay, so this is your general solution. Okay, so what I will do, I will solve one examples from each form. There is one last form. Okay, then I will upload a PDF containing lot of questions and their answers. Okay, you can easily learn them. So there is only one last form, actually not last, you got it. Okay, and this is my form 3. In form 3 I am dividing n here. Sometimes by dividing m you will get a function of y. Sometimes by dividing m you will get a function of y, and in that case there is another formula for integrating factor. So let's solve such type of form, like form 4, right? Form 4, suppose del m by del y minus del n by del x divided by m is a function of y. Say this as a gy or a constant then your integrating factor is integrating factor is e to the power integration minus gy dy. Remember this, here e to the power integration minus gy dy. Okay, so let's solve an example. So write this example here. Now see, first find del m by del y. So del y m, what is m? 3x square y to the power 4 plus 2xy. Partial derivative with respect to y. So 3x square is a constant. What is derivative of y to the power 4? That is 4y cube plus partial derivative with respect to y. So 2x is a constant. What is derivative of y? 1. So this is 4 into 3, 12 x square y cube plus 2x. Now del n by del x. Del by del x n. What is n? N is whatever multiplied with the dy. That is 2x cube y cube minus x square. Partial derivative with respect to x. So 2y cube constant. Derivative of x cube. Derivative of x cube is what? 3x square partial derivative with respect to x, derivative of x square is a 2x. So this is equal to 2 into 3 6 x square y cube minus what 2x. Clearly this equation is not exact. So now you will do what del m by del y minus del n by del x. This subtract these two. Okay, subtract these two. So del m by del y, this is 12 x square y cube plus 2x minus 6x square y cube. Now I am subtracting, so this will be minus, this will be what, plus 2x. This is 12 minus 6x square y cube, then plus 2x, that is 4x. Okay, now I can take 2x, I can take 2 outside, I can take 2 outside, 2 into, I will get what, 3x square y cube plus 2x. Now del m by del y minus del n by del x divided by m, divide m here. So you will find it 2 into 3x square y cube plus 2x whole divided by m. What is m? M is your 3x square y to the power 4 plus 2xy. Now 2 into 3x square y cube plus 2x divided by, now take y outside, you will find 3x square y cube plus 2x. Now see 3x square y cube 2x, 3x square y cube 2x, they cancel, so you have 2 by y. Now this is a function of y only. Okay, function of y only. Okay, so what was the form 4? Form 4 was if you are finding del m by del y minus del n by del x by m is gy, a function of y only, then the integrating factor is formula is e to the power minus integration gy dy, e to the power minus integration gy dy. So integrating factor equal to e to the power integration minus gy dy. This is equal to e to the power integration minus gy. What is gy? Gy is 2 by y, so minus 2 by y dy. So this is equal to e to the power minus 2 constant integration 1 by y dy. So e to the power minus 2 integration 1 by y is ln y. So e to the power again b into ln a, this is equal to ln a to the power b. So this is ln y to the power minus 2. Again e to the power ln x equal to what, x. In the last example I told you e to the power ln x is equal to x. So e to the power ln y, whatever this is y to the power what, minus 2. This is equal to 1 by y square. So integrating factor is 1 by y square. So now multiplying equation 1, right, multiply equation 1 by the integrating factor 1 by y square. We have what, we have what is equation 1? Here is equation 1 by y square. I will multiply 1 by y square here. So first I have to write the equation 1. So let's write the equation 1 here. I have a question in my book. So this is 1 by y square into 3x square y4, 3x square y4 plus 2xy dx plus 2x cube y cube minus x square dy. This is equal to 0 into 1 by y square, this is 0. Now remove the bracket, take 1 by y square inside the bracket. So 3x square y to the power 4 by y square plus 2xy by y square into dx plus 2x cube y cube by y square minus x square by y square into dy equal to 0 implies now y square cancel, 3x square y square plus 2x by y dx plus 2x cube y minus x square by y square into dy is equal to 0. Now give it equation 2. Okay, so now my new m is that is m1 is 3x square y square plus 2x by y. So what is del m1 by del y? So del m1 by del y equal to partial derivative with respect to y, 3x square y square plus 2x by y. This is equal to partial derivative with respect to y. So 3x square into derivative of y square is 2y plus 2x into derivative 1 by y. Derivative 1 by y is minus 1 by y square. This is equal to 6x square y minus 2x by what? Y square. My new n, that is n1 is 2x cube y minus x square by y square. Then del n1 by del x equal to del by del x of n1, that is 2x cube y minus x square by y square. This is equal to what is del by del x? Partial derivative with respect to x. So y, 2y constant. So 2y constant. What is derivative of x cube? 3x square. Derivative with respect to x. So 1 by y square is a constant. 1 by y square is a constant. Derivative of x square is a 2y. This is equal to 3 into 2, 6x square y. 6x square y minus 2 what is here? Partial derivative with respect to x. 1 by y square constant, derivative of x square is a 2x. Yes, this is minus 2x by y square. Now see 6x square y minus 2x by y square, 6x square y minus 2x by y square. So del m1 by del y is equal to del n1 by del x. So equation 2 is exact. So equation 2 is exact. And you know how to solve exact differential equation. Okay, how to solve exact differential equation? This is integration m1 dx plus integration n1 dy equal to c, terms without x and y constant, implies integration. What is m1? M1 is here. Let me erase all those things. Okay, so integration 3x square y square plus 2x by y dx plus integration terms without x. So here is x, so I will not write this term, I will not write this term as well. So 0 equal to c, y constant. हाँ जाऊजी. So y constant implies you have integration. What is y constant? Y constant means 3 y square constant integration x square plus y constant means 2 by y constant integration x dx equal to c implies 3 y square. What is integration x square? Integration x square is x cube by 3 plus 2 by y into what is integration x? Integration x is x square by 2 equal to c. So now implies 3 cancel. This is x cube y square plus 2 cancel, x square by y equal to c. This is your general solution. Okay, so these are the 4 methods of finding integrating factor. Another method, and there is no other method, but sometimes by guess you can find integrating factor also by just thinking without applying any of the formulas, or also in some questions you cannot apply any of the 4 forms. Okay, and there are one more thing to remember. There are infinite number of integrating factors. Infinite number of integrating factors. Okay, if the question is integrable. If the question is integrable. And second question is, and second important thing is, if uxy is an integrating factor, then some constant into uxy is also an integrating factor. Okay, so I'll do as many questions as possible in a PDF. Okay, I'll work out some problems regarding all these 4 forms in a PDF, and then I shall upload that PDF in the description of this YouTube video. Okay, so go to the description of this YouTube video, then you will find a PDF, and that video contains a lot of problems and their solutions regarding this exact differential equation and how to find integrating factor. Okay, and if you like this video, then please share and subscribe to the YouTube channel, and share these videos with your friends also. Okay, so thank you.